Hi guys, Mr. Cram here. So if you look at these rulers here, you got ruler A, ruler B, and ruler C. What I want you to think about is which ruler below will give the most precise measurement for the length of the metal strip. So this is a little metal strip here in each of these. So precise meaning if you were to use that ruler again and again and again, which one is going to give you the same measurement every single time or close to it? If you guessed ruler C, you are correct. That is the one you want to be using in this case to get the most precise measurement. And you might have made that decision based off of how many lines you saw. And that's a pretty good indicator here. We only have 2 lines in ruler A, so you're really kind of estimating how long this might be. You might say, well, there's about half, so this is less than half, maybe around 3.5 centimeters. With B, you get a little bit more specific information. You can see, all right, there are 10 lines in between. This is somewhere around 3 centimeters. But with ruler C, you can go even further. All right, there's 1 centimeter, 2 centimeters, 3. It's somewhere a little bit north or above 3 centimeters. So now that you've identified ruler C is the best tool to use to measure your metal, or give you the most information anyways, take a second and figure out how long this is. So if you took a second, got a little close here and said, all right, I know it's a little bit more than 3 centimeters. You might have said it was 3.1 or 3.2. Well, what you can really do is you're not sure on that last decimal, okay, when you're using this tool. I know it's around 3.1, but I can make an estimate of what that final digit is for this measurement of the metal piece. And that's what's important to recognize here, is that when we're using different tools in the lab, we can sometimes estimate a final digit, but depending on which tool we're using, we need to pay attention to how many digits we can actually get for the information that's wanted. So I call this final digit, or we call this final digit, an uncertain digit. So you're not sure about it, but you are pretty sure about those first 2, right? So there are a certain number, there's a certain amount of uncertainty anytime you do a measurement. And that uncertainty in this measurement is that last 5 there. I'm not certain about it. I am certain about the 3 and the 1. So we'll talk about these digits called significant digits. Will help us communicate what's important when we're measuring different things in the lab. So if we're going to measure maybe volume using a graduated cylinder, there's a nice little close-up view of the meniscus here, which is that curved part of the liquid when we're in the tube here. And if you were to look at the meniscus, you might say, okay, I know it's more than 40, and each line here represents 2 more increments. These are milliliters. So this would be 42, 44, 46 milliliters, but recognize and I'm thinking it's pretty close to that line right there. So I might estimate my final digit to be 0. So I can say with confidence it's 46, and then I'm estimating what that final digit, because my tool can't go any further. So we can always estimate the final digit when using a graduated cylinder to measure volume in the lab. With mass, our tool actually is going to estimate the final digit. It's confident with those first 3 in this particular tool. This one is called a graduated. It's called an electronic balance. That's what we use to measure mass in our class. And they're measuring the mass of some uranium metal here. And we have 4 digits clearly displayed on our tool, but this 4th one here is the estimated one. And our tool here, the electronic balance, actually does that for us. We don't have to make that up for the uncertain digit here. So, and you probably have seen something like this, and maybe even seen that last digit kind of go up and down a little bit. That's totally normal, because that's the uncertain estimated digit. So what are some rules to count how many significant figures we have whenever we have a number that's from a measurement in class? Well, there are 5 rules. Rule 1 says that all non-zero, so that's going to be a 1 through a 9, any of those numbers, they're always going to be significant. So in our particular number here, we have 123.4. That has 4 sig figs, because each of these are non-zero numbers, so we always include those for significant figures. Rule 2 says lone zeros after the decimal are always significant. So in this particular number we have a 1 point and then 2 zeros afterwards. We count these zeros as significant figures, meaning we are including them in our measurement to somehow give more information, give more precision to our measurement so that we can have a more repeatable number every single time. So there are 3 sig figs in this particular number. Rule 3, we have sandwiched zeros. I like to think of them as sandwiched because they're in between 2 non-zero digits. So this is kind of the meat and cheese of your sandwich. So they're always significant. So if you ever have kind of a situation where there's a non-zero out front and another one on the end here, any of those zeros in between are significant. So in this particular number, 1, 2, 3, 4, 5 sig figs, or significant figures. Rule 4 says lone zeros in front of a decimal are not significant. So in this particular number, this 0 that's out in front, we're not going to count it as a significant zero or a significant digit. We do count the non-zeros still, but this leading 0 in front of the decimal, it's not important. So there are only 2 sig figs here in this number. And finally, rule 5, leading zeros after a decimal but before a non-zero are not significant. So here we have this 0 in front of the decimal, so rule 4 already told us that that one's not significant, but these other 3 zeros in front of the non-zeros here, they are also not significant. So we only count the 6, the 2, and the 5 here as significant figures. There are 2 calculation rules that you need to know in regard to sig figs, and they're in a nice, neat little category. So there's an addition-subtraction rule, and then there'll be a multiplication and division rule. So the addition-subtraction rule says that the number with the lowest number of decimal places determines your answer's number of decimal places. So here's an example. We're adding these 3 numbers, 23.1, 16.01, and 1.008. So if you punch that into your calculator, you would get this number, 40.118. Well, let's count the number of decimal places that each of these numbers have to figure out why our answer is 40.1. So if you look at 23.1, I see that there's only 1 decimal place here. With 16.01, there are 2, and with 1.008, there are 3. So the rule says the lowest number of decimal places determines my answer's number of decimal places. So when I would get this in my calculator, I don't write out the whole thing. I only write out the 40.1 because that's what the rule says my answer should have. So I only have 3 sig figs in my final answer. If I wrote this out, I would report 5 sig figs, and that wouldn't be correct. For multiplication and division, the number with the lowest number of sig figs determines the number of sig figs in your answer. So here's an example, 3.1865 centimeters. We've got some units here to deal with because that's commonly how you'll see these calculations done, times 8.8 centimeters. Really quick, just determine your sig figs. The first one there, we got 5. This one we have 2. So our answer is going to be determined by the lowest number of sig figs. So our answer should have 2, right? We would punch this in and get 28.041 in our calculator, but we aren't going to write that whole thing out. We don't want 5 sig figs here. We only want 2. So we're going to round this just to 28, and the units are centimeters squared. Alright, here's a challenge problem. Got multiple operations here. I'll give you a moment, or maybe actually you should probably pause the video and write this out, try it for yourself, and I'll show you the answer. So here we go. I'm going to break this problem up into 2 operations. I'm going to deal with the numerator term first, and then I'll deal with the denominator, and I'll combine the answers. So 4.4 meters plus 8.312 meters. I'm adding here, so I'm going to use the addition-subtraction rule, which says the number with the least number of least number of decimal places, which is my 4.4. That determines the number of decimal places in my answer. So I should have 1 decimal place. 4.4 plus 8.312 gives me this. When I plug it in the calculator, I'm not going to write that whole thing though. I just want the 1 decimal based on the fact that this only had 1 decimal. With the second, the denominator term, I have 0.23 times 5.209. I have 2 sig figs here. I don't include the 0 here. That's the leading 0. I think that was rule 4. And then we have 1, 2, 3, 4. We got a sandwich 0, so I do count that. 4 sig figs here, 2 here. My answer should have 2 sig figs. So when I plug it in, I get this long thing. I don't write the whole thing. Actually, I round this up. The 9 here is going to make this round up to 14 meters. Finally, 12.7 meters divided by 14 meters. Here we have 3 sig figs, here we have 2. It's a division problem, so my answer is going to have 2 sig figs based on my denominator. I get 0.90714. I don't write this whole thing out. Again, I only write out 0.91. I'm actually rounding this up 1 to here. So that's my final answer. So this is what you would want to report, and if you notice too, I'm putting boxes around my answers. That's a very good strategy to start employing. If you can always box your answers, your final answer, it doesn't leave any question about where your answer is. So, what should you have learned here? All measurements are going to have some uncertainty represented, but there's going to be some estimated digit. Okay? It depends on the tool you're using, how many estimated digits you actually, how many digits you have total. There's always going to be that last digit on the end that can be estimated. You should know now how to count the number of sig figs, which is an important skill, because when you are doing the calculations, you need to be able to determine sig figs to get the right answer in the correct number of sig figs.